So January 2022, question number 10. This says 3 points O, P, and R are shown in the grid below. O is the origin. Write the position vector OR in the form AB, where in the form you're going to write the position vector OR as a column vector. All right, this is how we go. So this is the position vector OR. Now, a position vector is a vector that is tied to the origin. So this is the position vector OR. Now, to get from O to R, I'm going to go 1, 2, 3, 4, 5 units to the right and 1 unit up. To get to R from O, I'm going to go 5 units to the right and 1 unit up. So the position vector OR is the column vector 5, 1. So the top value represents horizontal movement. The bottom value represents vertical movement. All right. If you're moving to the right, the top value is going to be positive. If you're moving to the left, the top value is going to be negative. If you're moving up, the top value is positive. If you're moving down, the top value is negative. This says another point Q is located in such a way that QR is 2 minus 4. Using this information, plot the point Q on the graph. I thought that this was very interesting. All right, so QR is saying that in going from Q to R, I must go 2 units to the right and 4 units down. Now here's the problem. I don't have Q on the board, but I have R on the board. So you know what I'm going to do? I'm going to find out what is RQ. So RQ and QR are inverse vector. So whatever QR is, RQ is the negative of it. Whatever QR is, RQ is the negative of it. So since QR is 2 minus 4, RQ is minus 2 minus 4. In other words, this is minus 2 positive 4. A negative times a positive is a negative. A negative times a negative is a positive. So this is telling me now, in going to Q from R, I must go 2 units to the left, 1, 2, and 4 units up. 1, 2, 3, 4. This is the position of Q. So in moving to Q from R, I must go what? 2 units to the left. And so that's 1, 2, and 4 units up. 1, 2, 3, 4. This is the point Q. We're asked to plot the point Q on the graph. So this is Q. Next, what are we asked to do? I thought that was interesting. We're asked to determine the magnitude of Q. Now, QR is, the vector QR is, I think, 2 minus 4. Yeah. So the magnitude of QR. So remember how you find the magnitude? It's going to be the square root of 2 square plus minus 4 square. This is going to be the square root of 4 plus 16. This is the square root of 20. So this is 4 point something units. So the square root of 20. And this is 4.47 units. This is 4.47 units. All right. Next, we're to show by calculation that OPQR is a parallelogram. Guys, we need to ask ourselves, how do we show that a quadrilateral is a parallelogram? Now, a quadrilateral is a parallelogram in which opposite sides are equal and parallel. By showing that one pair of sides are equal and parallel, you're showing that the quadrilateral is a parallelogram. So once you can show that one pair of opposite sides are equal and parallel, you're showing that the shape is a parallelogram. Going back to our diagram, this is our that is our shape. All right. So let me just draw it free and all right. So this is our shape. We're now asked to show that this shape is a parallelogram. We have QR and QR. All right, we have OR as well. OR is what, 5, 1. So we could use OR 5, 1. Let's find PQ. PQ. So PQ. In going from P to Q, I'm gonna go what? 1, 2, 3, 4, 5 to the right, 1 up. PQ is also what? 5, 1. So what we're seeing is that what? PQ and OR are equal vectors. PQ and OR are equal vectors. So I can go back to the question. Could say that PQ is, the vector PQ is what? 5, 1. And the vector OR is also 5, 1. So these two vectors are equal and parallel. And these two vectors are equal and they are on opposite sides of a quadrilateral. So what that means is that the line PQ and the line OR are equal and parallel. Why? They are equal and parallel because OR and PQ are equal vectors. OR and PQ are equal vectors. If they are equal vectors, it means therefore that the line used, the line for the line representing the two lines representing the vectors are of equal length. And because the two vectors are equal, they must be what? Parallel. All right. So these two lines are equal and parallel. Therefore, OPQR is a parallelogram. How do I know it's a parallelogram? Opposite sides are equal and parallel. Once I can show opposite sides, one pair of opposite sides are equal and parallel, I'm showing that it is a parallelogram. B says calculate the value of X and Y in the matrix equation. All right, so this is a matrix equation and we need to calculate the value of X and Y. So let's multiply the two. We can't compare elements in a matrix unless the two matrices are of the same order. So let's multiply the 2 by 2 matrix on the left by the other 2 by 2 matrix to get another 2 by 2 matrix. So this is going to be row by column. First element in the row 1 times the first element in the column -4. 1 times -4 is -4. Second element in the row 5 by second element in the column 2. 5 times 2 is 10. Just multiply the top row by the left column. Now top row by the right column. We have what? 1 times 1, 1. 5 times 9 is 45. Bottom row, left column, 2 times minus 4 is minus 8. Y times 2 is 2y. All right. Then we have what? Bottom row, right column, 2 times 1 is 2. Y times 9 is 9y. And the matrix on the left is equal to the matrix on the right, which is x, 46, 6, 65. Stay with me. Therefore, we're going to have 6, 46 minus 8 plus 2y, 2 plus 9y. This on the left is equal to on the right. So what that means is this. So if two matrices are equal, corresponding elements are equal. Corresponding elements means elements in the same position. So since 6 is the top left on the right, and x is the top left on the right, sorry, 6 is the top left on the left, and x is the top left on the right, x is equal to 6. And bottom left, minus 8 plus 2y, minus 8 plus 2y is equal to bottom left, which is 6. 2y is equal to 6 plus 8. 2y is equal to 14. Divide both sides by 2, and we get y is equal to 7. X is equal to 6, and y is equal to 7. Last page. The transformation T, represented by 0, 1, 1, 0, maps S, which is 2, 5, onto S prime, which is 5, 2. Describe the single transformation T. All right, so what happened in this transformation, and you all need to review transformation properly, is that the X, in this transformation, S, which is 2, 5, is mapped onto S prime, which is 5, 2. I could do a quick sketch of it to give an appreciation. X is 2, 5. So 1, 2, 1, 2, 3, 4, 5. This is S. S is 2, 5. And it's mapped onto 5, 2. 1, 2, 3, 4, 5. 1, 2. This is S prime, 5, 2. The line passing dead between them. This is the line y is equal to x. Here and here are equal. Now, the only way you have a situation, the transformation which maps S to S prime is actually a reflection in the line y is equal to x. So whenever you have a transformation in which the x and the y coordinates interchange, that transformation, so the transformation T is a reflection in the line y is equal to x. So the transformation that interchanges the x and y coordinates of a point is a reflection in the line y is equal to s. Sorry, y is equal to x.